So, okay, we've got the carbon equivalent value of the steel itself. We've got the hydrogen scale of the consumables. We've got the heat sink. And the third point there is how hot are we actually getting the weld? Because the hotter we get the weld, then the longer it takes to cool down and the more time there is for the hydrogen to diffuse. So that will be the arc energy. That will be usually something to do with kilojoules per millimeter, because we've got the volts, we've got the amps, and we've got the travel speed. So we can then use kilojoules per millimeter as our measure of arc energy. Now this table may look complicated, but it's really useful because it tells you we've got different inputs into deciding if we've got a problem or not. This table is telling us the maximum thickness before we need to preheat. We probably don't want to preheat because it's inconvenient and it's going to be additive to the cost. So we'll be trying to not preheat. So what's the maximum thickness we can have? And that will be the maximum combined thickness. If you like, a little reminder of the total heat sink. What's the maximum combined thickness we can have without preheating? So over on the top left-hand side, let me see if I could even get an annotating tool. Here we are. Over on the left-hand side, look where we are highlighted in sort of pinky color. In the left-hand scale, we've got lots of hydrogen in the deposited weld metal. We've got at the top of the table a higher value of the carbon equivalent, 0.49, compared to over on the right, 0.43. So those are kind of onerous things. And we've got a low heat input, 1 kilojoule per millimeter. So all those things together, I know people say I use the word onerous too much, but they're quite onerous. And therefore we're limited to a maximum thickness of 25 millimeters for the combined thickness. On the bottom right, well, we've got a low hydrogen scale. That's the left-hand part of the table. We've got a lower carbon equivalent value. That's the top of the right two columns. And we've got a high heat input. And that's all good news because the maximum combined thickness is 100 millimeters. So the responsible welding coordinator is going to balance and team and ladle all these inputs to come up with an appropriate weld procedure specification to assure us that the weld can be completed without defects. The responsible welding coordinator may use charts like the one we see here. And this chart, if we start on the right-hand side, this chart is for hydrogen scale B, so that's the top of the line, and it's for a maximum carbon equivalent value of 0.45. So you might say that B is bad news because there's lots of hydrogen, but the carbon equivalent value is relatively low at 0.45. This chart is also good for hydrogen scale E, which is low hydrogen, but the carbon equivalent value is rather higher at 0.55. So there's lots of different charts for lots of different combinations. So the first thing is to find the appropriate chart for the particular combination that we're interested in. So in this instance, it's hydrogen scale B and a carbon equivalent value of 0.45. The bottom scale is the heat input in kilojoules per millimeter. And you remember that 2 kilojoules per millimeter was one of those values on the previous slides. The vertical scale on the left-hand side is the combined thickness. So I'm intersecting 100 millimeters combined thickness with 2 kilojoules per millimeter arc energy. And where I intersect, I'm reading to the higher value, which is 100, and that's 100 degrees centigrade. That says for this particular combination of B and 0.45 carbon equivalent value, for an arc energy of 2 kilojoules per millimeter and a combined thickness of 100 mil, I need to preheat to at least 100 degrees. Well, I don't really want to do that, So probably what any self-respecting responsible welding coordinator would do would be, for example, to change the hydrogen scale of the consumable. So now we've found a different graph, which is for a lower hydrogen scale, scale C. It's still for the same carbon equivalent value, 0.45. We've still got 2 kilojoules a millimeter. We've still got 100 millimeters combined thickness. And now we're down at 50 degrees C. Well, I still don't want to do that. So I would go off and find another graph for perhaps an even lower hydrogen scale. Or I would look at the certificate for my steel and see what carbon value it actually had. So hopefully I can find a combination, which means I can complete the weld, in this case, without using preheat.